Right, okay, hello and welcome to today's video, which is going to be direct and indirect proportion. At the end of the video, I'm going to come back to a ratio 2 question that I got incorrect on the last video. But for now, we are going to jump into the videos, the stuff for today, which is direct and indirect proportion. So we're going to start off with our question 2. So making sure it's recording. It costs 75 pence to buy 5 bananas. How much would it cost by 7? So let's go through. So we're going to say it's 75 pence to buy 5 bananas. I'm writing B because, as you know, I can't bother to write bananas, and this is how we form algebra, through laziness, which is great. So bananas equals 75 pence divided by 5. We could find this using long division. So 5.75. How many 5s go into 0? 0. How many 5s go into 7? 1. Remainder 2. How many 5s go into 25? That's 5. So B is 15 pence. Now we want to find 7 bananas. So we want 7 times B, or 7 times 0.15. We find this using multiplication, so 0.15 multiplied by 7. 5 times 7 is 35, so we put a 5 in the hundredths column, and our 3 carries into the tenths column. 7 times 1 is 7, plus 3 is 10, so we do a 0 in our tenths column, and dot for the difference between pounds and pence, and the 1 carries over into the pounds column. 0 times 7 is 0, plus the 1 is 1. So our answer is £1.05. Right. If you need to go over it again before I erase it, pause the screen now, and you can just go over it. Okay, I'm going to erase all this, and we're going to go through to the next question, which is going to be the question 3, where it says 3 tins of beans and 4 tins of tomatoes cost £2.73. 5 tins of beans cost £1.55. Work out how much 1 tin of tomatoes costs. Okay, so there are 2 ways of doing this question, and I'm going to go through them both. One of them is through simultaneous equations. The other one is a similar method to the way we've just done. I'll do the way we've just done first, and then I will go through the simultaneous equations method. I know this isn't a simultaneous equations question, but it's just good to have that understanding enough that you can apply topics to other types of questions. And that's where those big 4 or 5 markers come in. They want you to be able to use stuff that you know in other topics. So we're going to, like I said, we're going to start off with the way we know first, and then the new way second. So 3 tins of beans, so I'm going to write B for beans, plus 4 tins of tomatoes, so I'm going to write 4T, equals £2.73. 5 tins of beans costs £1.55. So the first way we're going to do this is we're going to solve for B. We're going to solve for the beans, and then this is going to be our equation 2 and our equation 1. We're going to solve for the beans. We're going to solve that value of beans into our first equation and then solve for the tomatoes. So how do we solve for beans? We do long division. So 5, 1, 5, 5. How many 5s go into 1? 0. But we're going to carry that 1 over. How many 5s go into 15? 3. How many 5s go into 5? 1. So we know that the beans are going to cost 31 pence. Now we can plug this value into our first equation. So 3 beans, or 3 lots of 31 pence, plus 40 equals £2.73. And like I say, this B, I've just plugged it into here, and that's how I've got this equation here. So 3 lots of 31, that's 93, you can work that out yourself, or you can just look at this 31, 3 times 0 is 0, 3 times 3 is 9, 3 times 1 is 3. So we're going to have 93 pence plus 40 equals £2.73. So we want to solve for t now, because that's what the question asks. The question says how much is 1 tin of tomatoes. So we're going to take off 93 pence off both sides. We can work out this right hand side using subtraction. So 273, 0.93, subtraction. 3 minus 3 is 0, 7 minus 9 we can't do, so we pinch 1 off the 1, put it here. 17 minus 9, that's 8. 1 minus 0 is 1. So 40 equals £1.80. And now we can just divide by 4 on both sides to solve for t. That gives us 45 pence. You can do that using long division, but I'm just saving a bit of time. So that is the first way of doing this. I'm going to do a big line here because I'm going to show you the other way on this side. I think my webcam comes up to about there, so I'm going to use this space underneath, this space here. Quickly erase that. Awesome. And here is the second way of doing it. So 3b, I'll write the same thing down again, 3b plus 4t equals 273, 5b equals £1.55. And you see how I've made sure everything's in line, so the values of b are in this column, the values of t are in this column, and the monetary values are in this column. That's very important, and I'm going to show you why now. So we're going to call this one 1 again. We're going to call this one 2 again. But this time we're going to manipulate the whole equation, right? We want to find the lowest. We want to look to see what's common in both of the. We want to see what variable is common in both of the equations. We can see it's this here because there is a b in equation 1 and a b in equation 2, so we're going to mess around with that. So we're going to find the lowest common multiple of these two things, that's 15. So we're going to multiply this by 5, going to multiply this by 3. So 15b, because that's 3 times 5, plus 20t equals, now this one's a bit difficult, so we're going to do multiplication. 273 multiplied by 5. 3 times 5 is 15, so we can do a 5 and the 1 carries. 3 times 5 is 35. We can add 1, 6, and 3 is going to carry. 2 times 5 is 10, plus 3 is 13. The 1 is going to carry. So we have £13.65. So we're going to write £13.65 here. Now we're multiplying this bottom one by 3, so 15b equals, and again we can use just multiplication, £1.55 multiplied by 3. 3 times 5 is 15. 5, 1 carries, 3 times 5 is 15, plus the 1 is 6, the 1 carries, 3 times 1 is 3, plus 1 is 4, so this becomes £4.65. And now we want to subtract. We're subtracting the bottom line from the top line, so £13.65 minus £4.65. Now we could use the basic subtraction, or we could just notice something. 65 here, 65 here. Anything after the point is going to become 0. because it's just subtracting itself. 13 minus 4, that's 9. 15b minus 15b is 0. 20t minus nothing is 20t. So now we have an equation we can solve, because we're looking to solve for t. So we can say that 20t is 9, so t equals 9 over 20. We can find that out using long division. 9 over 20. How many 9s go into... No, sorry, that's the wrong way around. I'm always going to do something mixed up. Right, the number you're dividing by goes in the... So, yeah, 29. So how many 20s go into 9? 0. So we do a little point and we carry the 9. How many 20s go into 90? 4 remainder 10. So we do another little dot. We do a 10. How many 20s go into 100? That's 5. Don't forget to put your 0 and your point. That becomes 0.45, which is exactly what we got over here. So those are your two ways of solving this question. That was direct proportion, and I believe the next question is indirect, so let's get on to that now. It takes 3 machines, 2 days to produce a batch of products. Work out how long it would take 1 machine to produce the same batch of products. So let's have a look. So let's imagine 3 machines. And altogether it takes these 3 machines 2 days. Now we are going to cut these machines. We're going to reduce the amount of machines by 1/3. So we've gone from 3 machines to 1 machine. We have divided by 3. Now because this extra machine is having to put in a way more effort, because this machine's putting in the same amount of effort, it's going to take it longer because these 2 machines aren't here. So we've divided the days, but we've divided the machines, but we're going to multiply the days because this is inverse proportion. So whatever we're doing to the machines, we have to do opposite to the days. This becomes 6. So the answer is 6 days. And there is your answer. Algebraically, we can say that we would put it as 3 equals k over 2. And we would solve for k. K is what we'd be looking for. K is the 1. We times both sides by 2. And k equals 6. Some questions might ask you to say, how long would it take 4 machines? So in this case you'd solve for k and then you divide k by 4, and we'd say that it would actually take 4 machines 1.5 days. Anyway, let's go to the next question. So the answer for this question is 6 days. Right. X is inversely proportional to Q. X is inversely proportional to Y. X is given by the following formula. X is 1,000 over Y. Find the value of X when Y is 50. So for this question, we just want to do long division. So we are going to do 50, and we want to do 1,000. So how many 50s go into 1? None. How many 50s go into 10? None. How many 50s go into 100? 2. And how many 50s go into 0? 0. So there we go. The value of X is 20. This question is quite nice. It's just a plug-in and work out question. So 50 times 10 to the 6 is 1,000. 1,000 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 times 10 to the 6 is And anyway, let's go on to the next question. This is another similar question. The force F is between two magnets is inversely proportional to the square of the distance. F is given by this. So when it says inversely proportional to the square of the distance, we say that this variable here is some number divided by what it's inversely proportional to. So that's why in the other question I said when I said that it takes the machines a certain amount of days to do something, we put the machines equals k over the days, and then we'd solve for this unknown number by multiplying both sides by what's on the bottom. In our case it was d, so we'd say that k is d multiplied by m, which in our case was 6. So our formula for f, or in our case our formula for machines, would be 6 divided by the number of days, or vice versa, the number of days would be equal to 6 divided by the machines. So that is what indirect proportion means. You can simplify it as to look something like this, is when the two variables, so in a regular graph it will be x and y, are multiplied together to equal some unknown number, a, which could be 7, which could be 14, which could be high, which could be anything. But yeah, so that is how we solve that. And anyway, we're going to actually get on with the question now. So f equals 36 over x squared, when the two distances are 3 centimeters apart. So we want the square of the distance. The distance is 3, so we want to square that. 3 squared is 3 times 3, which is 9. So f equals 36 divided by 9, which is 4. So the force is 4. And that's that question done. We're going to go to the last question for this topic. This one was an optional because it's quite hard, but what I'm going to do, I'm going to go through it with you now. So let's have a look at the question. Here are 4 graphs. Sketch each graph and match with a statement in the table below. Y is directly proportional to x, y is inversely proportional to x, y is directly proportional to x squared, y is inversely proportional to x squared. So when we have a graph of y being directly proportional to x, we say that y equals kx. Which one of these could look like that? Well, when y equals kx, it is just a straight line. B is the only one with a straight line in that direction, so we're going to put the letter B here. We're going to rub that out, and we're going to have a go at our next one. Y is indirectly proportional to x. So, going back to our last question, y equals k over x, yx equals k. For the purpose of this, and for the fact that these graphs look rather uniform, we're going to assume that k is 1. So 2 numbers multiplied together to get 1. So we're looking for something where we want 2 positive numbers or 2 negative numbers multiplied together. So if x is 1, y would have to be 1. If x was 2, y would have to be a half. If x was minus 1, y would have to be minus 1. So if we draw a basic graph where we have 4 quadrants, and here is x and here is y, this is where there's a positive x and a positive y. This is where there's a positive x and a negative y. This is where there's a negative x and a negative y. This is where there's a negative x and a positive y. Because we go along this way is the negative direction. So our x here is negative. And if we go up from here, y becomes positive. So our y is positive. If we go down from here, y is negative. And we're looking for a pair of positives or negatives. We're looking for a graph which has something in this quadrant and this quadrant. So if we look, we can see that this A here has a slope here and a slope here. So it's going to be that one. We're looking for A. Interestingly though, if k was a negative, if yx would equal minus 1, or xy equaled minus 1, it would look something like this, where it would be in the other quadrants, because we want two numbers together. We want a positive and a negative, or a negative and a positive. Okay, I'm going to carry on with the next one. So our first letter was B, and our second letter was A. Y is directly proportional to x squared. Now imagine an x squared graph looks something like this. Just look for one that looks like that, which is D. And the nice thing is we can just go through process of elimination now. There's only one left, and that is C. So y is indirectly proportional to x squared, looks like this, where y x squared equals 1, or y equals 1 over x squared. So that question was quite difficult. If you don't follow it, just go through it. Try going through it more slowly. Or if you still don't get it, send me an email and I will go through this question more slowly. The last thing we're going to do is that we are going to... That's not what I wanted to do. There we go. I want to go through this question here. This question that I already actually attempted, but I wasn't recording because I'm an idiot. So let's go through this question now. Given that AC is 1,6 and BC is 2,5. Now this question, I misread the question, and this is something that is vitally important that we don't do. This is why when I was in bed watching the video on my phone to make sure everything was right, I realised that, oh, I got the question totally wrong. So this is something that you should be doing in your exams. If you have time at the end of your exam and you've gone through all the questions, or you've gone through all the ones you can do, go back through the ones you have done and go through them, read your writing as if it's not your own, and try and see if you've done everything you think correctly. Because if you make those mistakes, it can sometimes be the difference between a grade 3 and a grade 4, or a grade 4 and a grade 5. So let's have a look at this question. AC is 1,6, so AC is 1,6, BC is 2,5, find the ratio of ABC. So we're going to do our common, we're going to do our three-part ratio, ABC. We're going to put the information from these into here. So A1, C6, we're going to write a 1 in the A column and a 6 in the C column. B2, C5, we're going to do a new row. We're going to put 2 in the B column, and we're going to put 5 in the C column. And now we want to identify the row, the column, sorry, that has a common variable. Which one of these two things, what letter is in both of these? And we can see that it's the letter C. So we highlight this, and we say, what is the lowest common multiple of 6 and 5? Well, if you just multiply them together, we get 30. So let's just multiply this row by 5 and this row by 6. So now this becomes 5 colon 30 and 10 to 30. And in fact, I've just got that wrong. This should be a 12. 6 times 2 is 12. So we smush them together, so we get our A, B, C. We take our 5, put our 5 in. We take our 12, we put our 12 in, and we take our 30, we put our 30 in. And that is the answer for that question. That is the correct answer for that question. Now that is the end of the video. I will be going through, next I will be going through reverse percentages, which shouldn't take me too long because all those questions were in essence the same kind of question. As long as you can do one, you can do them all, so that one shouldn't be a very long video. And then once that video is out, I shall be going through Maths Genie and setting you some more work. So yeah, that's this video done. Thank you for watching, and I will be with you for the next video, whenever that shall be released.